Let n be a natural number, then the LCM of n and n plus 1 is, we have 4 options. How can we solve this? In this case, I will straight away write the answer. The answer will be n into n plus 1. That is option C. Why? It's given that n is a natural number, okay? So for any natural number, the numbers n and n plus 1 will be coprime. You take any natural number n, then that number n and the next number n plus 1 will always form a coprime. So let us look a bit more deep into this. You take any number, okay? Take any number. What are the smallest factors possible for it? The smallest factors could be 1, okay? It can be 2. We don't know the number n, but it can be 2. It can be 3, okay? And the next prime number is 5, okay? It can be 7 and so on. Fine. Let us assume that 2 is the factor, 2 is the smallest factor for the number n, okay? Now what will be the next smallest number such that 2 will be the factor? That will be n plus 2, okay? Let us take one more example, and this time let us assume that 3 is the smallest factor for the given number n, okay? Then what will be the next smallest number which is having 3 as the factor? That will be n plus 3, okay? In the given problem, we have two numbers n and n plus 1, and we just saw that if 2 is the smallest factor, then after n it has to be n plus 2, which is not the case here. Similarly, for the given two numbers, let us assume 3 is the smallest factor, then after n the next value has to be n plus 3, but we have n plus 1. That means that 1 is the common factor for n and n plus 1, or n and n plus 1 will always form a coprime. Clear? In the given question, we were asked what is the LCM of n and n plus 1, and that is going to be n into n plus 1, or the direct multiplication of n and n plus 1. What will be the HCF of n and n plus 1? The HCF of n and n plus 1 will come to be simply 1. If 3 is the least prime factor of m and 5 is the least prime factor of n, then the least prime factor of m plus n is, we have 4 options: 11, 2, 3 and 5. In this problem, we can write m as a number, and it is given that when it is prime factorized, 3 is the least prime factor. So we can write m is equal to 3 into some numbers, okay? Similarly, n, it's given that 5 is the least prime factor, so I can write n is equal to 5 into some numbers. So whatever be this number, okay, we do not know the other set of numbers. Similarly, for n, we do not know the other set of numbers, but irrespective of whatever these numbers are, we are multiplying this number with the value of 3 for m, and we are multiplying this number with 5 for n. That means m is an odd number. Why? Because we are multiplying it by 3. Similarly, n is also an odd number. Why? Because we are multiplying by 5. So what will happen if we add two odd numbers? It is going to be an even number. Now before we move ahead, some of you may have a confusion that how can we say that for a number m which can be written as 3 into something, it can always be odd. 6 is a multiple of 3 and that is not an odd number, that will be an even number. Then how can we write this? The thing that you have to understand is that It is given that 3 is the smallest prime factor for m. That means 2 doesn't exist in this prime factorization. Okay. If 2 was there, then there is a chance of m becoming an even number. But in this problem, 3 is the smallest factor for m. That means m will always be an odd number. In the case of 5, we have the same thought process. One of the first prime number that you can think of when we look at the multiples of 5 is 5 into 2 is 10. 5 into 2 is 10 and 10 is an even number. But again, 5 is the smallest prime factor for the given number n. That means whatever this number is, it will always be a odd. So in summary, m plus n will always be an even number, and for an even number 2 will be the least prime factor. Okay, so the answer to the given question is 2. N square minus 1 is divisible by 8 if n is option A an integer, option B a natural number, option C an odd number, option D an even integer. So it's given that n square minus 1 is divisible by 8. So we can write n square minus 1, this will be a even number. Why? Because n square minus 1 is divisible by 8, and if it is divisible by 8, it means it is an even number. Further, this means that n square will be a this means that n square will be a odd number. Why? Because we have removed 1 from n square minus 1. Further, we can understand that n will be a odd number. Why? You take any perfect square which is an odd number. The square root of that will be always an odd number. Once more I will repeat. If a perfect square is an odd number, okay, then the square root of that particular number will always be odd. If we have some doubt, let us check some examples. What is 9? It's a perfect square, and what will be the square root of it? It will be 3. Let us look at another perfect square which is odd, 81. Okay, what will be the square root of it? It will be simply 9. One more example, 121. It's a perfect square and it is an odd number, and the square root will be simply 11. Again an odd number. We have a odd perfect square giving a odd square root. We have a odd perfect square giving a odd square root. We have a odd perfect square giving a odd square root. So the answer will be option C, an odd integer. Root 5 plus root 3 plus 2 is we have 4 options. This is a simple question. We are adding two irrational numbers with a rational number. Okay, so definitely this is not going to be a rational number. Why? So what will be the answer? It will always be irrational. So the answer is option D, an irrational number. If you are adding an irrational number with a rational number, it will always be irrational. Okay. Further to keep in mind is that adding any two positive irrational will always result in an irrational number. Note, it has to be two positive irrational. We can have a case that root 2 minus root 2 is equal to 0, and that is a rational number. Okay, so it has to be addition of two positive irrational numbers. If n is equal to 2 cube into 3 power 4 into 5 power 4 into 7, then the number of consecutive zeros in n is, where n is a natural number. We have already solved a similar problem earlier. I will quickly go through this. So n can be written as n is equal to 2 cube into 5 cube into 3 power 4 into 5 into 7. This is nothing but n is equal to 1000. Why? 2 cube into 5 cube will give 1000 into 3 power 4 into 5 into 7. Further 1000 into 3 power 4 into 7 into 5. I'll put this in brackets. This value, that is 3 power 4 into 7 multiplied by 5, this particular value, so we have an odd number multiplied by 5, that means this whole number will end with the digit 5 multiplied by 1000, that means altogether n will be having 3 consecutive zeros. So the option is 3 or option B. The total number of factors of a prime number is, we have 4 options, 1, 0, 2 and 3. In a rush, most of you will opt for option A, that is 1, but it is wrong. In the rush of the exam, you will be in tension mode. A lot of you may take the option A, that is 1, but this is wrong. Why? Let P be a prime number, then its factors are 1 and P, that means we have 2 factors. Okay? And therefore option C, 2 is the correct answer. If A equal to 2 cube into 3, B is equal to 2 into 3 into 5, C is equal to 3 power n into 5, then the LCM of A, B, C is given as 2 cube into 3 square into 5. Then the value of n is, we have 4 options. We can write LCM of A, B, C is equal to, let us write all the factors of all the numbers, that is going to be 2 into 3 into 5, and the highest powers, for 2 it is going to be 3, for 3 it could be 1 or n, and we will assume that n is greater than 1, so n, and for 5 it is going to be 1, and this is equal to 2 cube into 3 square into 5. This means that n is equal to 2. It's a simple problem. Option B will be the correct answer. 119 square minus 11 square is a, we have 4 options, prime number, a composite number, a odd prime number, and fourth option is an odd composite number. At first glance you can see that option A and option C are funny. Why? Because all prime numbers are going to be odd except for number 2. Nevertheless, we can write 119 square minus 11 square. Let us write like this. 119 square will become some number and it will end with 1 for sure. Minus 11 square will end with another number and that will also end with 1. Okay. So what will be the overall answer? Any doubt here? 119 square, if I take the actual value, it will end with the digit 1. Why? We have 9 here, and that means 9 square is 81, and this number will end with the digit 1. Similarly, 11 square, this number, it will end with the digit 1. Why? Because 1 square is going to give 1 and that will come here. So when we subtract 11 square from 119 square, like we are doing here, we will get a value as 0 and some number. So this number will end with the digit 0, that means it is going to be a even number. So option A and C are going to be wrong because it is not a prime number, and option D is wrong because it is not an odd number. The final answer is option B, a composite number. If the LCM of two prime number P and Q, P greater than Q is 221, then the value of 3P minus Q is, we have 4 options, 4, 28, 38 and 48. How do we solve this? It's given that LCM of PQ is equal to 221, and it's given that P and Q are prime numbers. That means 221 is equal to simply PQ. That is the direct multiplication of the two numbers. Why? Because P and Q are prime numbers. So the question is, what will be the value of 3P minus Q? In this problem, 221 is relatively a small number, and it is a result of a product of two prime numbers. So we can quickly think of two prime numbers such that if I multiply P and Q, it should get 221. So what we can do here is that we can think of the values of P and Q such that when I multiply PQ, it will end up with some number and having 1 as the last digit. So what are some possibilities? So it could be something like PQ is equal to some value P, maybe 3 is the last digit of P and 7 is the last digit of Q, and this can end with some number ending with 1. Okay, you can quickly try some numbers for P and Q, that is some prime numbers P and Q which is ending with 3 and 7, so that we have 1 as the last digit of its multiplied value. And when you try, you will get PQ is equal to 13 into 17, and it's given that P is greater than Q, so P has to be 17 and Q has to be 13. Therefore 3P minus Q is equal to 3 into 17 minus 13, and that value is 38. So the answer is option C, 38. If 3 is the least prime factor of a number A and 7 is the least prime factor of number B, then the least prime factor of A plus B is, we have solved a similar problem before. Anyway, I'll go through this quickly. So A is given as some number with 3 as the smallest prime factor, and for B it's given as 7 is the smallest prime factor. This means that A will always be a odd number. Why? Because 3 is the smallest factor of A. Similarly, B will always be a odd number. Why? Because 7 is the smallest prime factor for B, and all other prime factors are going to be odd. So when we multiply one odd with another odd number, it will always be a odd number. The same logic can be applied here once more. 3 is the smallest prime factor of A, and all other prime factors are always going to be an odd number. So when I multiply one odd number with another odd number, it will always be a odd number. And when you add two odd numbers, it will always be a even number. Or for all even numbers, 2 will be the smallest prime factor. That means option A, 2 is the answer. A pair of irrational numbers whose product is a rational number is, we are given 4 options. We will go through one by one. The first option is root 16 and root 4, and so we can write root 16 into root 4. This is equal to 4 into 2 is equal to 8. This is a rational number and this is a rational number. That means we are multiplying two rational numbers, and option A is not the one we need. We move to option B, root 5 into root 2, and that will be square root of 10. Now this is going to be an irrational number, and root 2 is also an irrational number, and square root of 10 is also going to be a irrational number. So option B is also not correct. Option C is root 3 into root 27, and this is equal to root 3 into, this I can write as 3 into 3 into 3, or root 3 into 3 root 3, or this is going to be, so in this process when we look at option C, we have the two numbers going to be irrational in nature and the multiplied value is a rational number. So for the given question, the correct answer is option C. Any one of the numbers a plus 2 and a plus 4 is a multiple of, we have four options, 2, 3, 5 and 7. Have all of you understood this question very clearly? So we have three numbers a plus 2 and a plus 4, and any one of these numbers has to be a multiple of either 2 or 3 or 5 or 7. So let us understand the question clearly. Okay, so we have the numbers a plus 2 and a plus 4. Okay, let us understand the question clearly. If option A, that is 2, okay, if 2 can divide any of these numbers, okay, then that is a correct answer. Once more, let's assume that option 3 is the correct answer. That means 3 will be able to divide either a or a plus 2 or a plus 4. Similarly for 5 and 7. Once more I will repeat. Let us assume that option A is the correct answer, that is 2. Okay, this means that the 2 will divide any of the three given numbers. The three given number are these three. So 2 will divide any one of these numbers. We don't know which one, but any one of them. Similarly, let us assume that option B is the correct answer, that is 3. That means 3 will divide any of these three numbers. We don't know which one, but any one of this. Now how can we solve this? We will go option by option, starting with 2. If you divide any number by 2, okay, we have two possibilities for the remainder. What are those? 0 and 1. If 2 perfectly divides a number, the remainder will be 0, right? And if 2 imperfectly divides a number, that means the number is an odd number, then the remainder will be 1. First, let us look at a case when 2 perfectly divides a. Okay, then what will be the remainder in each of the scenarios? So if 2 perfectly divides a, then remainder for the given number a will become 0. For a plus 2 again, the remainder will be 0. For a plus 4 again, the remainder will be 0. Why? Because 2 perfectly divides a, that means 2 is an even number, right? And a plus 2 and a plus 4 will also be an even number. So if 2 perfectly divides a, we have remainder equal to 0 and we have the same remainder in both cases. Now we look at the second scenario. 2 imperfectly divides a. Okay, in this case the remainder will be 1 for number a, and for a plus 2 again it will be 1, and a plus 4 again it will be 1. Why? Because when we divide a by 2, it is an imperfect division, so we have remainder 1. That means a is a odd number. If a is a odd number, then a plus 2 also will be an odd number and a plus 4 also will be a odd number, and we will have the same remainder. So with respect to 2, we have only two remainders possible, r equal to 0 and r equal to 1. And in scenario 1, we see that all the numbers are perfectly divided by 2, leaving 0 as the remainder. So any of the number is a multiple of 2. And in the second scenario, we have a remainder as 1 for all the three numbers. That means none of these three numbers are a multiple of 2. That means we do not follow the given criteria of the question, that is any one of these numbers should be divisible by 2. That is not possible because the remainder is 1. Therefore option A 2 is not the correct answer. Okay. Now we'll go to the second option 3 and we will check. Now the second case, if you divide the number by 3, okay, we will have 3 possibilities for remainder, that is 0, 1 and 2. If you divide any number by 3, okay, then we will have 3 possibilities for remainder, that are 0, 1 and 2. So we have 3 scenarios. If 3 perfectly divides a number and the remainder will be 0. If 3 imperfectly divides, okay, then we have 2 scenarios, r equal to 1 or r equal to 2. Now let us look at the case with 3. So we start with the assumption that 3 perfectly divides a, okay. If 3 perfectly divides a, what will be the remainder? R will be equal to 0. And then what will be the scenario of a plus 2? The remainder will be 2. And for a plus 4, remainder will be 1. The second case, we look at the second case, 3 imperfectly divides a, and let us assume that in the imperfection case r equal to 1 or the remainder is 1. If a divided by 3 is resulting a remainder of 1, what will be the case when a plus 2 is divided by 3 and a plus 4 is divided by 3? The remainders will be 0 and 2. Now the last case, again 3 imperfectly divides a, and we already checked one possibility of remainder. Now we will check the second possibility, that is r equal to 2. Okay. Now when we divide the number a by 3, we got the remainder 2. Then what will be the remainder when we divide a plus 2 and a plus 4 by 3? We will get r equal to 1 and r equal to 0. Now look clearly, we checked all the 3 cases and we see that in each of this case we have a number that is perfectly divided by 3. Okay. Okay, and here we have a case. Once more I will repeat, we checked all the 3 cases of having remainders 0, 1 and 2, and we see that in each of the case there is at least one number that is perfectly divisible by 3. Okay, so in all the cases we have a number that is perfectly divisible by 3. Therefore option B 3 is the correct answer. Some of you may have a doubt that why we only considered 3 perfectly divides a, right? We didn't consider 3 perfectly divides a plus 2 or 3 perfectly divides a plus 4. Okay, I will ask all of you having these doubt to try the same exercise. Instead of a, you try a plus 2, and then instead of a, you try a plus 4. That is 3 perfectly divides a plus 2. Okay, then you try 3 imperfectly divides a plus 2, and then you check 3 imperfectly divides a plus 2. Check both the cases of remainders. You will eventually get into the same possibilities.